All right, guys, here is part 2 of our area lesson. So first we learned how to find the area of a polygon. Now we're going to work with all kinds of complex shapes. They're going to be a lot of fun. They're going to require a lot of thought. They won't necessarily be real easy. So we need to make sure we work real hard to understand what we're doing and why we're doing it. The first situation here, it says find the area of a nonagon with a radius of 8. So we talked about our strategies. We draw a right triangle. We get the angle at the top. A nonagon means 9 sides. So we're going to do 360 divided by 18. So that's going to be 20 degrees at the top. The radius is 8. Remember that the radius is the hypotenuse. It's the longest side there. So we need to find the apothem and the missing base. It's going to take 2 trigonometries to get there. So to solve for x, that would be the sine of 20 degrees would equal opposite over hypotenuse. So x would be 8 sine 20. And the apothem would be the cosine of 20 equals apothem over 8. So the apothem would be 8 cosine 20. So the actual area on this question would be 1/2 times the base, which is 8 sine 20, times the height, 8 cosine 20. And because it's a nonagon, there would be 18 of them. So that would be half of 8 times 8 times, so I would do 8 times 8, that'd be 64. Half of 18 would be 9, so 64 times 9. So that 64 times 10 is 640. So if you do 640 minus 64, that's one way you could do it. That would land you on 580, 576. And don't forget there's a sine 20 and a cosine 20. Practice trying to do this stuff in your head, my friends. So that's the exact number, which we got. We also want rounded to the nearest whole number. So if I actually type in 576 times the sine of 20 times the cosine of 20, rounded to the nearest whole number would be 185. Practice those things. Next picture, it says the area of a square is 400 units squared. So if I work on the square, area equals s squared. Write the formula down. That means 400 equals s squared, so s equals 20. So the sides of our square are all 20. Then it talks about the triangle is 100 units. That's the triangle over here. What is the height of the figure? Well, the height of the square is 20. We need to know the height of the triangle. So I'm going to work on the triangle. That is 1/2 base times height. We know that the area is 100. We know that the base would be 20. And we're solving for the height. So 100 equals 10h. The height is 10. So what is the overall height of the figure? Well, it's 10 plus 20, which is 30. We're going to be doing a lot of complex figures. Every individual shape has their own height. The overall figure has a height. There's lots of heights, guys. Circle the thing you intend to be the answer. Like there's going to be lots of things called h. I won't know which h goes where. So you need to be careful on what h belongs where, and also circle the ones that you intend to be answers. All right, the area of a rhombus is 6√7 centimeters squared. Sorry about that. And one diagonal is 2 centimeters. So a rhombus formula is d1 d2 divided by 2. We know that the area is 6√7. We know that one of the diagonals is 2, so it would be d1 times 2 divided by 2. It doesn't matter which diagonal, I just chose d2. Well, the 2's would cancel out, so d1 equals 6√7 centimeters. Now, that's the same number, but it's not the same thing. Area is in squared units. This is at 6√7 squared units. This is 6√7 linear units. This is a length, and this is a square. Not the same thing, but they are the same number. That's okay. Find the percentage of the shape that is shaded. Let's talk about percent real quick. Let's say that I have 60 coins and I have 11 nickels. And I want to know what percentage of the coins are nickels. How would I do it? I want you to think for a second. So how do you do percent? You would take the 11 nickels, you would divide by 60 and multiply by 100. So in that case, it'd be 11 divided by 60 times 100. That would be 18.3%. That's what it is. So percent equals the part you care about divided by all of it times 100. That's how you get percent. We need to know that. We're going to use that. So for this shape, find the percentage that is shaded. Let's look. Let's come up with a plan. If we do the trapezoid minus the sector, right? And just in case you weren't here, guys, a sector is this thing. It looks like a piece of pizza. A sector is a part of a circle. If I do the full trapezoid and subtract the sector, would I be left with the shaded area? Yes. Basically, I do the whole thing minus the white, and I'm left with the shaded. So this would be the shaded area divided by the total, which would be the trapezoid, times 100. So it's shaded divided by total times 100. So we need the area of the trapezoid. Let's start with the trapezoid. So the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. And on this problem, we need to do some work. We drop this down. That's a 60. This would be 30. That means that this little part would be 5. Look at your 30, 60, 90 there. And this would be 5 root 3. Also, because this is a sector, if this distance is 10, then this distance is 10. The radius of a circle is equal in all directions. So that means the base, the whole thing is 23. So 12 plus 23 divided by 2 times the height, which is 5 root 3. Let's practice doing this in our head. This would be 35 over 2 times 5 root 3. That'd be 150. That'd be 175 over 2 root 3. By the way, you can write it as 175 root 3 over 2. Those are the same thing. They're both times root 3. That's exactly what we want. So that's the trapezoid. Let's go work on the sector. Oh, we already did brown. Let's go work on the sector. Area of a sector is the entire circle times the part that we have. Now, if you have a whole circle, isn't that 360? So that would be 360 divided by 360. Well, that's just 1. So that means the whole circle is just pi r squared. But how much of it do we have? We have 60 degrees. So I'm going to reduce that. 60 out of 360 is 1/6. In other words, this sector is 1/6 of a circle. So the area is going to be pi times 10 squared times 1/6. That's how much we have. Well, that's going to be 100 over 6, which reduces to 50 over 3. Don't forget your pi. All right, so let's implement the plan. It's going to be trapezoid 175 root 3 over 2 minus circle or sector 50 over 3 pi divided by trapezoid 175 over 2 root 3 times 100. And I'm going to type this in, but guys, this is a tough one. You start with the fraction key. You do 175 root 3, put that over 2, minus 50, put that over 3 times pi, all over 175 root 3 over 2 times 100. And I'm going to show you what this looks like because you got to be able to type this in the calculator. Notice when I did this, I actually started with a fraction. I hit that first. Then I typed in the 175 root 3, and then I arrowed out of it, and then I made the fraction again over 2. That's where I got that. So if I scroll up, you can kind of see what I did. I'm not going to do the whole thing again, but you got to know how to type these in. It's not super easy. All right. And the answer was 65.451. Next situation, find the area. There's a lot of ways you could split this up. I suggest cutting it across here. And what we have is this little piece would be 5. So the trapezoid would be base 1 plus base 2 divided by 2 times the height. Well, this entire base would be 7 plus 5 would be 12. So that would be 12 plus 15. The height here would be 4, right? Because if this is 6, then this would have to be 4. I know I'm going kind of quick. So what would that be? That would be 27 times 2. That would be 54. So the trapezoid part is 54. The rectangle part is 30. The overall answer is 84. Parallelogram is base times height. So the area equals base times height, but you can't do base times height unless you have a right. No rights, no heights. You gotta fight for your heights. You could drop a height this direction, and you'd have a hypotenuse of 14, or you could drop a height this direction, and you'd have a hypotenuse of 12. Either way is fine. You can do either one. I'm going to do the one that's more vertical. I think it's a little bit easier to see. So if I drop this down, this is the right triangle I'm working on. I need to know this number. I'll call it x. So that would be the sine of 40 equals x over 14. So x equals 14 sine 40. And the base in this case would be 12. So the area equals 14 sine 40 times the base of 12. Well, that would be 14, be 140 plus 28, be 168 sine 40. You could type that in, but it'd be 168 sine 40. Next question, equilateral triangle with a perimeter. Find the area. We got to get really good at equilateral triangles. Remember, these are all 60s. So when you drop the height, it's a 30, 60, 90. Well, this would be 10 root 5 if the perimeter is 30 root 5. Divide by 2, 5 root 5, and then times root 3. This would be 5 root 15. So the area would be 1/2 times the base times the height. Let's practice doing this without a calculator. Half of 10 would be 5. 5 times 5 would be 25. Root 5, root 15. This is 25, root 5, root 5, root 3. I'm really sorry about the announcements. They're very loud today too. Remember, when we break down radicals, we want to split it up into GCFs. So if that's a 5, sorry about that, guys. Root 5 and root 5 equals whole number 5. So I took the 15 and I made it root 5, root 3 so that I could do root 5 times root 5, which is whole number 5. So that's 125 root 3. And that's the best way to do that problem. Find the area of a square with a diagonal of 14. Guys, think about our chart. Kite goes to rhombus, goes to square. We can use the kite formula. So if I know the diagonal, that would be 1/2 d1 d2. That'd be 1/2 times 14 times 14. So that would be 7 times 14. That's 70 plus 28. That's going to be 98. Squares are honestly the easiest shape. I hate using that word, but you can just do so many things on a square. They use all the formulas. They have all these isosceles right triangles. There's so many ways to solve a square. But if the diagonal is 14, I would just use the diagonals. Find the area of an equilateral triangle with an apothem of 8. This gets a little wacky, but if the apothem is 8, you can do this several ways, but one way you can do it is to treat it like a regular polygon, where there would be 6 of these. So you do 360 divided by 6, and it would be a 30, 60, 90. So this would be 8 root 3. And that means that the hypotenuse here would be, oh, we don't need that. We need to know the area though. So this would be 1/2 times the base times the height. And because it's this triangle, there would be 6 of them. 6 of them. So what would I do here? I would probably do 8 times 8 is 64. Divided by 2 is 32. So 32 times 6 would be 180 plus 12, be 192 root 3. This is just one way to do it. Here's a high-level maneuver. I didn't even show this in class, but you could get this number. If you remember back in the day, we learned that on an equilateral triangle that the median is split 1/3, 2/3. So this would be 16. So you could, like this would be 24, and that would make this piece here, 24 divided by root 3 would be 8 root 3. So you could do 1/2 times 16 root 3 times 24, you'd get the same answer. That's doing it on the whole triangle. I think it's a little bit easier to treat it like a polygon. And then we have this kite inside of a rectangle. So I need to know this distance, and I need to know this distance, because it's asking for the area of this rectangle, QHTM. Okay, so I'm going to break it down into a few triangles, but if that's 8 and that's 90 because it's a kite, this is a 45, 45, 90. So this would be 4 root 2. This would also be 4 root 2. That would make this 4 root 2. So if I'm focusing on this rectangle, which is QHTM, QHTM, well, Q to H, I know, is 8 root 2. I got that from the kite properties. Over here, this would be 25. So if I take this right triangle, I'm going to draw it over here. We have a 25 and a 4 root 2. Call this x. So the tangent of 25 would equal 4 root 2 over x. X would equal 4 root 2 over the tangent of 25. So that would be this distance right here, which is the one we want. So this would be 4 root 2 over the tan of 25. So the area of that rectangle would be base times height. For this problem, that would be 4 root 2 over tan 25 times 8 root 2. Well, what's 8 root 2 times 4 root 2? That would be 32 times 2. That'd be 64 over tan 25. Okay, that's the last one there. Those are some tough problems. I get it. Keep looking at them, keep working through, keep trying to figure out what I did and why I did it, and we're going to keep getting better. Let's go, guys. See you, babies.